implemented several technology solutions across Etihad and its airline partners to maximize Etihad's $6 billion top line. As a data scientist, he worked on Bayesian forecast models, AI, ML, and optimization. As an airline revenue management expert, he consulted 10 plus airlines across the world on the revenue management strategy from Survey Airlines Solutions Dallas. Yashwanth sir is from IIT Madras, where he majored in computer science and engineering. His minor studies were in operation research. Thank you, sir. And thank you, Anji Reddy, and hand over to Anji Reddy.
Yeah, thank you, Mr. Acharya, such a good introduction of Mr. Yashwanth. And I would like to thank Y.S. Rao garu. Sir, if you want to speak a few words about this gathering, please speak.
Yeah, let me. Hello.
Hello, sir.
Yeah, am I audible?
Yes, sir. Yes, sir.
Okay. Good afternoon, ladies and gentlemen. This is our, a great event and great evening that we are starting now. And yeah, so my name is Y.S. Rao. I'm also part of Edwisely. I'm taking care of the strategy of Edwisely. And I have almost 20 years of experience in the consulting and IT consulting, ERP consulting, worked with different organizations. And I welcome all of you. Maybe, when I do my session, I'll give more information about myself. I introduce myself and everything. And I thank Lindy's Institute of Engineering for providing this opportunity to, interact with all of you, to present our team to explain on this industrial artificial intelligence. Okay, so I wish everyone who participated or participating, if you have any questions, please raise your hand and we'll love to explain in detail. Thank you very much.
Hello. Thank you, sir. Hello.
Yes.
Yes. Hello.
Hello, Anjali.
Yes, sir. Yes, sir. We are hearing.
Yeah, I'm done with that.
Sir.
So
yes.
Maybe Yashwanth can.
Yes, sir. Start. Yeah, I request Yashwanth gar to proceeding with their presentation.
All right. Firstly, thank you very much, Anjireddy Garu. It's a great opportunity. I see about 90 participants in this FDP program. It's great to see so many people coming together to talk about artificial intelligence. Obviously, there are a lot of technology challenges. Even though we are talking about artificial intelligence, basic internet, Zoom is still not as easy to master as it could be. But we'll try our best in these 3 days. Let's try to make the best use of this. So before we get started, once again, I thank Chairman Garu, Matsudan Rao Garu, Srinivas Rao Garu, and Secretary Sir Shivaramakrishna. Your principal, you said, is a dynamic person. I would love to listen to him. V.V. Ramareddy Garu, and of course the conveners who are the HODs for CSC, EEE, and Mechanical. Co-conveners Anjay Reddy Garu, I've been in touch with you all throughout, and you made it a very comfortable process. And of course Acharya Garu for that brilliant introduction of mine. Thank you very much. So we'll get started. I'll start by sharing my screen. Can you all see my screen?
Yes, sir.
Yes, sir. All right. Okay. So yeah. So this is the beginning of this session, especially is the beginning of a 2-hour round on discussion on the industrial artificial intelligence. It's with primarily faculty members of engineering colleges and MCA colleges, I believe. the last statistic that Anjireddy Garu has given me was that 50% of the audience, of the faculty members, come from some kind of a computer science background, and the rest of them come from either a electrical background, ECE electrical, and rest of the department's background. So I'll try to make this the whole conversation this afternoon as a fairly open discussion. We will touch upon various aspects of industrial artificial intelligence, where it is being used, what is the history. We will get into those details. But to set a context, it will be from an industry perspective all throughout. All right, that is the objective of today's session. While we are doing that, I also want to emphasize that we'll be broadly spending 50% of the time talking about how artificial intelligence has evolved, how it has shaped up our society, and the other half taking directly into where it's being applied today and what are the various aspects in which it is being utilized in industry. So we will have this spread over the next 2 days, starting from today. So we'll get started with it. So artificial intelligence is the future. How many of you agree with it? I'm sure most of you do, right? So, okay, another aspect is whenever I want to make this as interactive as possible. So if you have something to say, I'll be actively looking at the chat window as well. So if you have something, please do chat, type it in, and I'll try to take a break in between and see what you guys are saying. Okay. Okay, I will get back to the presentation. Okay, so artificial intelligence is the future, right? Now, how many of you have interacted with some form of artificial intelligence today? Okay, I see that there are some responses that says Apple and Siri. Anything else? Alexa, great. What else? Come on, use the chat option. Let's make this more interactive. Okay, Watson to an extent. Anything from your daily life? Chatbots, when you're doing support, definitely. Alexa, if you have it. Siri on your mobile, you're probably having, most of you might be having Siri or an Alexa equivalent on your mobile phones. Anything else? Anything that most of us must be using? Google Assistant, that's right. Home appliances, yes, definitely. They can also work with AI. Anything else more simple, more fundamental? Gmail, fantastic. Bhaskaran sir, thank you very much. I think I was waiting for that example, and you've been bang on it. So Gmail is a classic example that most people forget when we are talking about artificial intelligence, right? So whenever somebody says artificial intelligence, people tend to think about large systems, very complicated systems, data flowing in, a lot of buttons and a lot of LEDs glowing in green color, and so on and so forth. But it is extremely prevalent in today's world. We have artificial intelligence that is interweaved into every aspect of our living. That is reality. So artificial intelligence as a thing of future is actually something which would have made sense 5 years in the past. Today, if you look at how artificial intelligence is brought into everything that we do, starting from Gmail to Facebook to Instagram, to figuring out how your credit card frauds happen, everything that you can think of in your daily life, there is some element, if it is something to do with a computer, there is some element of artificial intelligence that is running. How many of you have, most of you must be having a antivirus software, correct? All antivirus softwares today are using advanced artificial intelligence, machine learning to understand patterns when programs run on your computer. They keep evaluating how resources are being consumed. It looks at how different aspects and different communication writes and reads are happening out of your basic kernel. And it tries to figure out what is actually a program that is helping you run the system effectively, and what is a program that is probably consuming way too many of your resources and passing it on to some other third party without your permission. So everyone who's using a Windows machine, you can say technically that you are using artificial intelligence. This entire Zoom call that is happening, there are multiple layers in servers. There are multiple layers in terms of your firewalls that use AI and machine learning aspects immensely. So the answer to the question, did you interact with AI today? The answer is a resounding yes. And we are already in a place where AI has become almost our daily life. We don't have to look for some kind of a robotic human being who can speak to us, who can communicate with us. The aspects of artificial intelligence are very, very unknowingly already involved. Your smart compose of Gmail, like Bhaskaran sir has mentioned, it has become very common. In the US, self-driving cars are getting more and more common these days. A lot of research is going into it. Your Uber, the kind of recognition that it does in terms of getting a car closest to you, to your doorstep, and also taking to your destination in the shortest possible time. The pricing that goes along with it, it's completely AI driven. Airlines have been using AI for the last 30, 40 years in various forms and in various shapes, be it the revenue management algorithms that go in from, you must have all noticed how the price keeps changing, right? When you're booking a ticket from day one to say 3 months in ahead to the day of booking, the price almost quadruples. It increases by 4 times. And who gets to have what price is determined by a large complex system of algorithms. And that was my work for the last 5 years when I was in airline industry. So we will get started with our presentation. I'll just give you a short introduction over and beyond what Mr. Acharyalu sir has just mentioned. So I run a company called Edwisely. It is into learning science. We are an AI-driven learning company. A lot of aspects of AI that we are talking, I gathered and I learned from my experience as in Edwisely. So my colleagues, Y.S. Rao sir and Prahalya ma'am, they're both on this call. So they have been pivotal in terms of taking this company to the next level. We are doing a lot of work when it comes to learning. We will have one of the use cases in learning, how AI is actually helping learning get better for students all across the world. So that's another aspect we will touch upon in this 3-day FDP. I've studied in IIT Madras. It was a huge honor going there. I studied in the Department of Computer Science. I worked with people like Dr. Kemani, who is one of the top 10 computer scientists and artificial intelligence expert of this country. He has written multiple books on AI as a topic. I was in his class. I have done research along with him. We have built, gaming algorithms as projects. We have created new music out of a AI program back in the day. So we have done a lot of seminal work for that time period, along with professors like Narayan Swamy and Ravi Subramanian and so on and so forth. So it was a great time being in computer science. I worked with multiple distinguished faculty members, as well as industry teams like Cognizant's Center of Excellence for Artificial Intelligence back in the day. I also authored a course which is called the Data Science Mindset. This is for professionals who have more than 10 years of experience in the industry on how to solve business problems with a data science mindset. So large companies especially have this challenge of introducing new technologies into their process flows, on changing their revenues, changing their business models, and making more better decisions using data that is sitting with them over maybe tens and decades of information that they have been collecting. So how do you start extracting that information, creating insights out of it, and drive business growth? Business growth was the tenets of this course. So we have authored this course along with my CTO from Edwisely. So both of us have run this course for some time. I also work, like Acharya sir was mentioning, at 2 companies. One is Etihad, which is an airline that I'm sure most of you are aware of, and another company called Sabre, which produces software for airlines all across the world. So my role there was in the solutions and innovation space, where we were building a lot of AI-driven solutions to increase the top line. Top line is basically the revenue, which was at Etihad about $6 billion. we had both passenger side as well as cargo side. So I was looking into both of them and creating better and better algorithms to not lose any money that is on the table. That was my forte. A lot of customer segmentation, a lot of data that was going into the airlines. Airlines tend to collect a lot of data, right from where the booking is happening to the terminal code, to how many times have you logged into the system, how the decision of a buy has happened, what are the various different networks through which the booking has passed before it landed up with the host airline, and things like that. So I was leading a team of about 10 people. We were looking at a lot of projects that was driven using artificial intelligence, data science, and trying to push the revenue upwards. I also started something called as a Data Science Bites. It's an Instagram channel. It has about 624 followers. It's the latest thing that we have. This was started very recently, but I keep posting a lot of informative data science related, artificial intelligence related, posts for people who want to be. I'm sure if you're on Instagram, you must have had some data science channel that you're following. The Instagram and a lot of data science channels are, I feel like it's a great way of exchanging information. A lot of us can learn from others on what they are doing and how it is going forward. So this is about me. So at any point in time, if you have any questions, like I said, the group chat is available. Just type it in, I'll be taking it. So what we will do in this FTP, we will cover a lot of industrial use cases. That's one aspect of it. The other half is going to be about the basics of artificial intelligence, because like I said, 50% of the audience are probably not very well aware of the various things that happen in artificial intelligence. So we will take some time, go through some details and discuss a lot about how things are and what are the building blocks basically for building an industrial solution for using artificial intelligence. So we will cover different sectors and applications. I think you must have all seen. We will look at facial recognition and robotics, applications in chatbots, voice recognition systems, and something in learning, what we are doing and what we are good at. So we will also at the end of it figure out how to model an industry problem. So we will cover one end-to-end cycle so that we know, okay, from data collection standpoint to the final calibration and deployment standpoint, how does a typical process looks like, so that you'll get a hands-on view without actually starting to code on this webinar session. What it will not be, I want to be clear upfront, it is not going to be a lot of math. So it is not going to be a technical introduction to artificial intelligence, or you're not expected to code in this 3-day FTP. I love to talk about the math behind the algorithms, but it's typically a 4-credit course, which will last for the entire semester, for which we don't have time. So we will try to restrict it to the more non-mathematical part of the subject. I don't want to make it a lecture. I don't want this to be a one-way thing. If it was in a classroom where I would be there physically, I would have loved it because of the human exchange of information. It would have been far more exciting for me. But unfortunately, we have to make do with webinar due to the COVID restrictions. But still, I think we should not compromise on the exchange of ideas. So I would strongly, strongly urge all of you to participate. If you have a question, if you have a thought, if you have a comment, please do type it in the group chat. I have this open right here. So if there is something which I find catchy, then I will address it, and then we can have a discussion on top of it. Of course, we can still unmute and have a talk, but I think too many mics unmuted will create a lot of disturbance for the rest of us. So we will try to keep it structured and through the group chat. All right, can I see some yes, no, okay on the group chat, please? Awesome. Cool. All right, I think we are all warmed up now. It's here. What time is it? Okay, 3:20. Okay, so today's objectives, definition and understanding of what artificial intelligence is. We will try to understand how several people define it, whether the definition has stayed constant or has it been changing. We'll compare and contrast the landscape, how things are, different words that people generally use when they talk about artificial intelligence, because there's a flurry of information outside in the market and everybody talks about their thing to be the next big thing. So let's just look at the various terms. We'll pick up few of them. We will cover some of them tomorrow. in a more extensive way. And the third thing is the foundation and history. So this won't be a long foundation. We will take the highlights. What were the industry defining? What were the field defining aspects of artificial intelligence? And we will discuss about it. All right. That is the three things. Again, at any point in time, we can ask questions, but at the end of it, we will give it at least 15 minutes to have a more open Q&A once the entire session is done. All right. So yeah, let's start with our first part. So the definition and understanding of artificial intelligence is a bedrock to whatever we are doing, either in the industry or in academia, right? So the first definition of artificial intelligence has been about the ability of a digital computer to do tasks that intelligent beings can do. That was the pure play definition. So everything from adding numbers to to writing programs by the computer itself, everything was considered as intelligence at some level when compared to the human intelligence that was at play, that people knew. Human intelligence and animal intelligence, I would use it interchangeably. We will call it as human intelligence, but anything which is a life that is doing any task, we can still consider it to be a natural intelligence. That's what is the definition of natural intelligence. Any living organism that is trying to do aspects that are natural for them, that is all considered to be a part of natural intelligence. Artificial intelligence is more digital. It is done by machine, and this concept of machines doing intelligent stuff has been around since the Greeks and Romans. They have been talking about systems and machines that can do the work of human beings, especially the thinking part, especially the questioning part. And it has been in vogue from almost the time of Greeks and Romans. The massive change in the definition of AI came in about 1950s. That's when Alan Turing came into picture. He has made his famous Turing machine. We will talk about it in some time. And he, in several subsequent meetings and conferences, he encapsulated this definition that said, it is not just about counting and adding that makes an intelligence equivalent to an artificial intelligence capability. It is more to do with figuring out things that is natural for humans, but not so obvious for the machines. So that is the true definition as I put down in the second half of the slide. The true challenge is figuring out the things that humans and natural organisms have an intuitive feel to, and making machines do it. A classic example is facial recognition, right? Facial recognition is something that not just humans, but several organisms across the planet have an ability to do. Some of them do it within their own species. Some of them actually do across species. They can still recognize the unique characteristics of the other person. And the best part is, it happens at such an early age. Almost organisms, humans for instance, right? By the time they are 6 months or 9 months old, there is research that says that they can recognize their mom's face, and their the mother's face comes first, and then subsequently the rest of the family relationships. And by the age of 3, they have an ability to recognize close to 1,000 faces. So that's how advanced human brain is when it comes to facial recognition. In terms of computer vision, in terms of making a computer find out whether it is a known human face or not, it was only until very recently that major leaps and bounds in terms of that research happened, because of several factors, primarily because of the computing power that we have unleashed in the last decade. There has been a lot of increase in internet's bandwidth speeds that we are talking about. The cost of memory has substantially gone down, and to top it off, internet has become like a big rage. All the pictures that are being posted everywhere, everything that is happening on the internet is a huge data funnel for artificial intelligence research, right? So it's actually interesting that I was speaking to one of the senior researchers at Google X. It's also called the Moonshot Factory. That's where all the advanced research in AI happens across the world. And he was telling me that the act of sewing, act of stitching 2 pieces of cloth together, which is something that humans have probably been doing for more than 2,000 years. It is extremely difficult for a machine to be done. that's a problem. A similar problem is what they're working on how to make machines have the dexterity to actually stitch two things together, two pieces of cloth together. So while we think that artificial intelligence is already leaps ahead and bounds ahead, it is not really the case. There are still a lot of challenges that are not covered yet. And I think as we keep redefining artificial intelligence, as we keep moving the target away, we will start to realize that the definition of AI is not really one strict definition that will stand the test of time and space. It keeps getting reinvented as we keep progressing. It might be called with different names. For example, a lot of researchers, they call this aspect of describing, creating these solutions which are intuitive to humans but have to be formally defined for a machine, to be called as deep learning problems. But deep learning is still a very small subset of your entire artificial intelligence set. And as we keep getting evolving, we will keep finding those smaller and smaller sets of problems for which the real research and the cutting edge technology of artificial intelligence needs to be applied to master them and to solve them, right? So that is how we will be looking at artificial intelligence. AI and deep learning, we will try to use it interchangeably, because today's cutting edge AI is basically deep learning. So we will keep that in mind as we go along the 3-day webinar. This was the example that you're seeing here. It's basically a very simple problem that early researchers wanted to solve. The objective is to draw a line that separates the green triangles with the blue circles, right? It's a complex problem if you look at it like the left-hand side of the picture, the Cartesian coordinates. But when you transform it into a polar coordinate system where both of them get separated, we see that it's a very simple problem. Just with a straight line, you can separate both of them, right? In the first section, your accuracies will go for a toss. You will not be able to separate both of them accurately using a straight line. You would need a circle or something. So because all of us are engineers, I'm assuming that we all know Cartesian coordinates and polar coordinates. So we are not going into the details of it. So this is a problem that can be solved with transformation of axes, right? From an x and y coordinate Cartesian coordinate system, if you transform it into a polar coordinate system, you could solve this problem of separating the blue circles with the green triangles using a straight line. Now, if you look at it, while a computer can solve this problem, once you change the transformation still needs to be done by a human being, right? Now, take a note of this for a second and think about it, right? We are talking about artificial intelligence, but it's actually not a pure artificial intelligence system. It is an AI plus human driven system. So how the transformation happens, half the problem is solved by a human being. The human being is putting his intelligence into picture, and he is giving the system inputs on how you need to solve the problem. And that's when the system comes in, the AI system comes in and starts separating both the sets using a straight line. While there are infinitely many straight lines that are possible, what AI tends to do is to find that appropriate straight line that separates it in the best possible way. That is left to the system, because computationally AI systems can do a fantastic job. But when it comes to the idea or the thought process on the transformation of the axis, it is still driven by human beings, right? So this was the starting point for majority of AI problems that we look at. It was driven partially by humans and partially by machines. The transformation on what is the feature set, how it needs to be done, had to be thought through by a human, by the programmer, and then entered into the system, programmed into the system, and that's when the actual separation generally happens. So from this point, let's look at where AI is today. Now, this is the current traction of AI. So this is a standard image recognition process, how an image is broken down into several layers, right? And then it comes up and says whether it is a car, whether it is a person, whether it's an animal. And in some advanced system, if it is a person, then it looks at whether that person is wearing a cap, whether that person is happy, whether that person is sad, what is happening to that person, all kinds of things that you can think of. So there is, and here there is no human intervention at all. You just give it a large sample of photographs, and you write a multi-layer perceptron program or a neural network, a deep learning model into it, and you feed it, and it will give you, it will discover things that are part of the image by itself. Its job is to figure out what is happening within these bunch of images without any human intervention whatsoever. I think this is where the real, the real power of artificial intelligence lies, where you don't have to really have a human being to sort out things and say that, hey, you know what, look at it this way. Hey, you know what, this is a picture of a laughing woman, so you can cluster all these laughing women into one go. It will figure out that, okay, all the laughing women photographs are in one thing. You can call it laughing, or you can call it some kind of an emotion A, but the system is going to come up with the cluster that says, all right, these are all into one category. This is a standard classification problem, right? So all these are in one category, all these are in a different category. Of these two categories, there are overlaps within these categories. So the number of things that a computer or a deep learning program can do is insane. There are a lot of companies and a lot of technology giants that are working on figuring out new patterns in existing data patterns that humans were still not able to figure out. As you keep reading, there are, I think in recently there was a news article that said on how a PhD scientist in one of the top universities was put to test by a artificial intelligence system that one of their students have written, and things that took close to a decade for the professor to come up with, the program was able to do it in fairly short amount of time. So there are problems which can be solved by these deep learning solutions in a very, very quick way that will engage. What it does for the faculty members is that the professor can now spend his time solving more number of problems and go to the next level of learning, right? So in this example, as you can see, it's called a deep learning problem. There are multiple layers in which the problem of what is happening in that image solved. And as you keep giving more and more images to this learning system, it tries to take everything apart and figure out what are the patterns that are in the data. Is there a human being in the picture? Is it a person? Is it a car? Is it an object? What kind of colors is that picture having? And all kinds of things, right? So this is one of the classic deep learning problems in application today. When you upload something on Facebook, I don't know how many of you are still using Facebook, but when you upload a picture, it shows you the image. It shows a box and says, here is the image of your friend, and you should tag that person, right? I'm sure most of you have used that application, used that feature at some point or the other. So that's an application. It's a direct application of this technology there. It figures out in every new picture that is coming in, what are the faces, what are the facial components part of that image, and it reverse searches and says, this is the person's name and you should be tagging it, right? So this is how the latest or the current traction when it comes to facial recognition and artificial intelligence in general is. So this is the landscape that I call of where artificial intelligence is. So the large circle on the outside is where your AI is. It's everything from knowledge bases to, if you've heard about ontologies, that's where it is. Everything that becomes the foundation for artificial intelligence as we know it today is part of the overall block, right? An example that has been commonly used when it comes to AI is machine learning. That's where things like regression, things like supervised learning, unsupervised learning, all these things come into picture when we are talking about machine learning. Beyond machine learning, which is representation learning, is where we don't have any human to extract what are the things that the machine should focus on. So in machine learning, you still have a human in the loop. The human figures out what kind of information should the system look at in terms of separating. One standard example is, say you want to look at a So a common example that I generally keep referring to is you want to build a machine that can separate good mangoes from bad mangoes. All right. So how will the machine know whether it is a good mango or a bad mango? So imagine that it is a large factory. There are a lot of mangoes that are being packaged. This is something in the US. Obviously, in India, it's not, food processing is not yet so advanced. But in US, Florida produces a lot of oranges. So they have to do automated industrial packaging. So they have systems that will separate good fruit from bad fruit. Now, when you want to separate a good fruit from a bad fruit, the first thing is the computer needs to keep taking pictures of this orange. So you need to have a camera that keeps constantly taking pictures of every orange that passes through it. Once you have pictures in multiple dimensions, the system needs to figure out whether it is a good apple or a bad apple. Good apples go to the boxes, bad apples go to the trash. That's your separation. That's the simple process flow that you can think of. When we call something as a machine learning, what happens there is you give inputs to the computer program saying that, all right, take this image of an orange and then figure out whether there are any black spots on the orange. That is your criteria one. That is what we typically call as a feature set. The first feature is whether there are any black spots or is it a homogeneous picture. Number two could be whether it is symmetrical or not. If it is symmetric and if there are no black spots, you would call it a good apple. So your function would be something like good apple is equal to symmetry plus without any black spots. A bad apple would be a negation of a good apple. So that's how you separate oranges. Same thing if you take an example for a mango or any fruit, apple or whatever it is, it would be the same example. That is what we call as a machine learning process. When it comes to a representation learning, what defines a good orange versus a bad orange is left to the computer to figure out. There is no human intervention. So it looks at probably millions of pictures of oranges and it comes up with a function that says, all right, 90% of my oranges are in a certain way. It doesn't tell you what kind of features is it looking at. It could be shape, size, color, the redness of the orangeness of the fruit, or some kind of a heterogeneous nature or a homogeneous nature of that object. It takes into account a bunch of characteristics of those pictures and says, you know what, I'm going to characterize these kind of fruits into the good bucket. And it doesn't have to do with the human being at all. It just says that, all right, these are all in one bucket. I am only, you as the human, you just need to tell it one thing. What percentage of the apples you want to be classified as a good apple? That's it. You want it to be 90% accurate. It puts 90% of the best apples into one bucket. The 10% of the fruit is posted as a bad fruit. The 90% of it is given as a good fruit. You change the parameters, it keeps changing the way it is differentiating between a good and a bad fruit. So this is a standard feature that is used right now. There is enough computation power and in fact a lot of data to run representation learning algorithms. This is a standard example that happens when it comes to a machine learning algorithm and a representation learning algorithm. The more advanced part is a deep learning algorithm, where if you don't have a lot of images, it will still come up with a process wherein it keeps learning from what a previous layer has done. So think of deep learning algorithm as a bunch of representation learning algorithms together, where it looks at what is happening in layer one, takes that output and feeds it into another algorithm, which is it could be another machine learning algorithm. And we are talking about a bunch of algorithms that are going together that will give you a final output. So there are obvious difficulties when it comes to having such deeper networks. The error, if it gets carried forward, it amplifies a lot, and the stability of the model itself is at question. But scientists have figured out multiple methods. You might have heard something called as a generative adversarial network, which is very commonly used in deep fake technologies. The videos that you keep seeing on how people images and can be morphed from one video to another video. These are all being done because of the advances that happened in GANs as they are called, generative adversarial networks, which is part of the deep learning algorithm. So deep learning, like I said, is the core part of AI that is being worked on right now. All the super cool things that you watch on YouTube and Facebook, where you see about how facial recognition is happening, or how emotions are being captured out of a human being, all these things fall in the deep learning category. So that is where the most advanced of the methods are happening. So this is a very broad understanding level explanation of what each of the different words are, each of the different terms are. If you have any questions on this part, feel free to type into the chat box. No questions? Shall we go ahead? Yes, no? Yes, okay. All right. All right. So the second aspect of what we want to do today and talk about today are the various terms that we hear when we talk about uh, machine learning and we talk about artificial intelligence, right? So I've just put down a bunch of them. If you have any more terms that you can think of, you can keep typing it in. You can keep typing it in. Okay, we have one question from Mr. Bhaskaran sir. So his question is, how much of deep learning is being used in the industry? Assuming that we are talking about the industry today. Well, the answer to that is very, very little. What the big giants are doing is, it is still in nascent stage. Okay, the second part of question is it still in nascent stage? So the answer to that question is, when it comes to industrial artificial intelligence, it is, deep learning is still only scratching the surface. There are the big giants like Google, Microsoft, Amazon, and Facebook that are investing heavily into deep learning. Their objective is basically to commoditize deep learning, right? So they are trying to figure out how as a company they can start giving deep learning as a service. So if you think of how AWS has given cloud space as service, as storage as service, computing as service, so you don't have to buy your own server systems anymore. Thanks to AWS, you can directly subscribe to this much amount of RAM, this much amount of computing power, so many core processes is what I need. You can run all your computation on the cloud itself, correct? So in the same way, now Google, Microsoft, Facebook, Amazon, they're all fighting for the space where they can give deep learning solutions as a service, where they say that, all right, you have 10 terabytes of information, just give it to a particular a service that they provide, and they are the ones who they are going to process it, and they're going to give you the outputs that are required. So deep learning at that stage is what everyone is trying to crack, but it is at least, I think, 5 years away, if I have to take a guess. It's not actually something that I'm saying, but most of the industry says that deep learning as a service is still way far. One of my juniors, he is working in Carnegie Mellon University. I was recently talking to him. They are trying to figure out how to make robots move among people, right? That's their problem statement. His research is on that. So what is very intuitive to human beings, right? What is easy? It's very easy for even a child, at the age 5, the child can walk through humans and people around them without running into somebody. Maybe a 1-year-old cannot. The child will still run into walls or run into people or fall down and things like that. But humans quickly learn the ability to walk through spaces without hitting somebody or dashing into someone. For a machine, it is incredibly hard to do it. They still have to figure out if there is a slight deviation, how do you go back to the path? How do you keep going back to the path and continue to reach their destination without hitting into something and making some and hurting somebody? So this is a small problem, right? This is something that machines are struggling to figure out on how to do. It is called social movement of robots. That's what the subject is. You can learn more if you Google for it. But the essential line, which is very simple, which is how do you make robots move in a way that doesn't run into somebody or it doesn't hit anything. So this itself is a very difficult problem that took years and years of research, and they're still not finally there. The previous example, like I was saying, on how to do, how you can create a machine that can manufacture or assemble cell phones, right? Today, because of coronavirus and how China is being looked at, a lot of companies are trying to take away this entire dependence on human beings for assembly lines. They don't want to give opportunity to any other country, just like how they gave opportunity to China. Being reliant on their human power, their human resource power to manufacture stuff. But in reality, it's still far, far away to create systems that can replace human beings at workplace. You have robots, but they are trained to do a certain set of things, and that's what they do. And most of the research that you see, which is part of Facebook and TikTok, when they keep sharing those videos, they are largely at a prototype stage. There are very few exceptions. In this whole landscape, Japan is way advanced. They have implemented a lot of deep learning algorithms. China, when it comes to things like facial recognition, is way, way ahead, just because they have a lot of computing power and they have the ability. They bought a lot of companies, and their privacy laws and their government is very supportive of the technology. So except for in pockets, deep learning is not still largely engaged in industry. It is very, very geographically concentrated. It could be because of the company, because of the government, or because of some kind of an advanced, some kind of a funding that they have received. They might be trying some deep learning technologies. But in general, when it comes to industry, deep learning is still not very commonplace. It's still getting there. And the idea is whoever cracks that problem of making deep learning decentralized, accessible to everybody, will be the next Google or next Microsoft. As we know, that will be the next billion-dollar company. So that is one half. What I also want to share with you when it comes to deep learning in industry, the biggest consumer of deep learning today in the market is actually the IT companies. There is a lot of research that is going on how do you replace developers using deep learning algorithms. We've known, right? We've seen that a lot of programs are required to actually make artificial intelligence possible. But the real threat that people are looking at is how do you start building AI systems that are capable of replacing humans when it comes to IT itself. That is where a phenomenal amount of research is happening. IT is both the largest producer of AI as well as the largest consumer of AI in today's context. Thank you. That's a fantastic question, Bhaskaran sir. Any other questions from anyone? Okay. All right. So we will get started. So here is there is another question from Karthik Patnaik sir. What is cognitive AI? Very good question. It is very much contextual to the compare and contrast slide that I have in front of me. So cognitive AI, when we talk about cognition in general, right? Cognition is how humans think about a certain problem. It's more of a overlap between psychology and human, and artificial intelligence. So this is where people try to figure out how humans think and how do you reproduce that human thinking on through a machine. So this is again a very neuroscientist oriented topic, where you are reproducing how a human solves a problem. how things like reasoning happens, how things like consciousness or awareness happens. Very fundamental things like how do you how do feelings happen in an individual human being, right? So these are all part of the area of cognitive artificial intelligence. This is one area that is far away from any progress at this point in time. I think we have to solve a lot of deep learning problems to come to the part where cognitive AI really becomes a mainstream subject or mainstream research topic. One major uh, progress when it comes to cognitive AI is when humans, when they are interacting with robots, they have figured out that humans actually perceive robots as other human beings. This is called as anthropozation of robots. So humans are generally considering everyone as a, we tend to pray to sun god, and we think of sun as a human being, right? We think of mountains and sometimes trees as humans. That's where much of our mythology, the Indian mythology, also comes from. And when it comes to a similar concept applied to machines, there is a large section of people who have done, who've been thinking about how humans and machines can be starting to think together, starting to be overlapping in their nature of thinking, so that it solves the initial problems, or the problem of how a machine can be made much better. It is also, a lot of scientists believe that it is a path to understanding human thinking in itself. How does a human brain thinks and how does it operates is still a question of a lot of debate, right? It's still something that neuroscientists have not fully figured out. um, Cognitive AI is considered as a huge medical research tool for them to figure out the inner workings of human brain that will help neuroscience, and that will help people with paralysis, people with autistic diseases, ADHDs, and a lot of other things that come along with that understanding. So it's a completely different field, sir. It's actually more of neuroscience and less of artificial intelligence, and that's what cognitive AI is. All right. So yeah, so let's get back to this. If you have any questions, we'll pick it up after this. I saw that somebody raised their hand. Shall I? What do I do with that? Okay, we will. I think it's gone now. So we will continue with our session. Okay. So okay, the next thing, yeah, like we were talking about how all these terms that happen in AI, right? People talk about machine learning, people talk about regression, a lot of people talk about data science, and then there is data analytics, deep learning is what we were talking about, neural networks, forecasting, optimization, and then there are even more terms like clustering, classification, supervised, unsupervised learning, several things. So I've broken down into two sets because we will talk about the terms on the left side today in a very broad context that will give you an understanding of what it actually means. And terms on the right side is something that my colleague Prahalya will take in the first half of tomorrow's session. So she will get into the details of what technically a clustering would mean, what a classification would mean, what supervised learning is. Everything will be dealt with in a very structured way tomorrow for the first half of the session. So we will deal with the terms in AI now. Before that, I saw that somebody else again raised their question. Yeah, Subhash, do you want to ask a question? Subhash, sir? Okay, that seems to be a... Okay, that seems to be like a fluke thing. So we will get back to our thing. Okay. So yeah, so first thing, what is machine learning, right? Like I said, machine learning, simply put, it's basically humans identify what are the features that needs to be looked at, and the machine basically runs the classification or the clustering problem. So it it's a combination where humans basically model mathematically what is happening in the real world, and that's when and after that the machine takes over using a bunch of algorithms. This is typically what a machine learning system would typically mean. Machine learning is also the most used artificial intelligence methodology in today's world, right from your servers where you are getting a lot of information, lot of data packets through it, routers, all the information that is coming through it, it is completely vetted by machine learning algorithms, and then it is processed and insights are being brought in. So this is an extremely well known mathematical tool and an AI tool which is extensively used in all fields that we are talking about. In general, today's machine learning that we just said, including Siri and chatbots and all the examples like smart compose, credit card fraud, everything is basically machine learning as we know, right? So you have typically a bunch of a set of rules that you get a computer to understand. You program those rules in, you have a bunch of values that you need to tweak, and then you have any kind of your respected output will be brought out. Classic example when it comes to internet security, you are getting a bunch of data packets into your system. The machine learning algorithm basically figures out what is a right packet, what is a wrong packet. Same thing when it comes to spam. You keep getting a bunch of emails on your email, be it Gmail or Outlook or whatever it is. That information is being processed by the machine learning algorithm that says, hey, you know what, these are the features that you'll be looking at. One of the feature could be the recipient email ID, the address from which you are getting the email from. The second thing could be the kind of words that are used in your mailbox. The subject line's description could be the third one. So you have close to, I think, with Gmail, it is about 54 such features, what you call them as features, which it will be looking for. And it says, all right, these features is what I'm going to look at. And if the cumulative score is more than a certain value, if the function that I'm looking to evaluate whether it is a spam or not is beyond a certain number, then I will flag it as a spam and it will go to your spam box. The rest of the email will end up in your inbox. So this is effectively used AI tool, which is pervasive everywhere. Smart Compose is also a similar thing. In your Gmail, when you're writing an email, once you say that, hey, it will immediately look at the person whom you're sending the email to and say if it's Professor Anjireddy, then it says, hey, hi, and then it recommends your next set of words to be Anjireddy Garu or whatever that information is. So this is how a Smart Compose works, and this is also something which is run by a machine learning algorithm. It's a predictive machine learning algorithm that says that typically in your first line, when you're starting off with words like hi, hey, dear, hello, all these keywords, then you are very likely to use the second word as the name of the recipient. How does the system get to know that? Because it's been trained on all your past emails for the last 10 years. It look at how you have been writing the second word after a hi, hello, dear, and compares it with your email address, and then starts recommending what you need to put in. Machine learning is also extensively used in industry in the areas of predictive maintenance. Say you have a system like an aircraft engine, for example, and that keeps running for hours and hours together on a regular basis. If there is a requirement of maintenance, even before something goes wrong with the engine, it kinds of looks at multiple parameters like the temperature, the oil pressure, the air pressure, the within the engine, whatever is the parameters that are important from a mechanical engineering standpoint, looks at all these components and says, all right, in the next 7 days, there is a probability that the engine needs maintenance. And that's giving the indication or a red alert to the maintenance engineer saying that, all right, this needs to go for a C check analysis or a B check analysis, the different terminology to the extent at which the maintenance needs to happen. So it does these kind of predictions, and these are typically a machine learning algorithm, which is part of an artificial intelligence toolkit that is at play. Regression is when you have regression is basically fitting, right? The word regress means you need to fit it into something, you have to reduce, and reducing is basically the reduction of errors. And regression as a tool is actually part of the machine learning toolkit. And when it comes to, just like how machine learning is the most commonly used AI tool, regression is the subtool within machine learning that is most commonly used. Because any predictive algorithm, any forecasting method, any optimization method is basically you're reducing something to the minimum. Generally, it is the error that you're trying to reduce. So regression happens to be the most commonly used subtool within the machine learning toolkit. Data science is a very vast term. Data science is, in fact, the foundational science behind artificial intelligence. You can look at it's basically knowledge science. When you say data science, you're trying to look at loads and loads of information, what you typically called as data when you're speaking the language of data science, when you're talking in the language of computer science, and you're trying to get patterns and knowledge out of it, right? This becomes the foundation for entire artificial intelligence, because without data, there is no artificial intelligence, right? You need to have digital information. You need to have records. You need to have various amounts of labeled and unlabeled data for you to run any of these algorithms that we are talking about. So data science is anything from gathering data to processing data, figuring out what is the outliers in the data. So outliers is basically good data and bad data, right? So there could be a sudden, say, a power cut because of which you haven't collected data for 1 hour in your when you're doing your sensor data collection. That 1 hour of data loss can be recorded as a 0 in your values, but it's not really 0. If, for example, if you're looking at the same example of temperature of a temperature of, say, an engine that you're testing in your automobile lab, when the engine continuously keeps running and you're getting information of the temperature and bunch of other sensors, and you keep collecting all this information. Suppose there is some kind of an electrical disturbance or some kind of an issue with the sensor because of which it shuts down intermittently. Should you be considering it as a data point, or should you be avoiding it from entering your data model, right? This kind of differentiation, you need to have a data scientist looking at this data and running his outlier detection models to figure out whether this is a data that can be input to the AI model in itself. So data science is everything from, like I said, collecting to processing to figuring out outliers to slice and dice analysis, all these things together. And then you get your machine learning algorithms at the far side of data science. From data science, from machine learning, you would enter the artificial intelligence half of the project. So like I said, data science is in large letters here because you cannot separate data science and artificial intelligence. Data science has been there for data science is actually the input to not just artificial intelligence, to multiple areas of research, both in across multiple domains of sciences, right? The classic example that I get to hear is the initial days when laws of heavenly bodies were given out by Ptolemy and scientists like that back in 1700s. The whole analysis of geographical of geospatial positioning and how planets revolve around other heavenly bodies was all data science. It was all gathering data, gathering positions of different planets, different stars all across the year, and then trying to fit them through a bunch of mathematical equations. That's what data science has been. So there is no start point for data science to say so as to say. It has been there from a really, really long time, and it has been the essence of most of scientific endeavors in in the history of humankind, right? Data analytics is, it's an interchangeable word when you talk about data science and data analytics. Analytics is what you're analyzing from data. Analyzing is breaking down stuff. It's breaking down stuff. So once you get into this huge mammoth of data under your control, the techniques that you use to visualize and bring insights from this data is what we would call as a data analytics part. So it's basically a subset of data science. You can call it a subset of data science, and data analytics is what a lot of businesses are today using as a separate team in itself to drive intelligent decisions within the companies. So in short, bringing out insights from data is what the eventual business output of data analytics is, and to drive actionable result oriented actions within the organization is the endpoint of what data analytics would mean. Moving on to the next one, when you talk about deep learning, we've been talking about deep learning till now. Deep learning is a super, the core of what artificial intelligence is going in today's world. It is the area where a lot of cutting edge research is happening. It is a green field. If there are a lot of researchers among you, if you are professors at colleges who have to, if you have to, work on a research project, I would strongly recommend you make your PhD scholars and your master's students to start looking at deep learning methods. There is a bunch of things that are needed to be done. There are a lot of new ideas that the industry is expecting. A lot of research publications will immediately accept anything that you're talking about in deep learning. Neural networks is also a kind of deep learning. It was one of the initial layers of deep learning was looked at as a neural network. In neural network, essentially, it is called neural network because for the first time, scientists have started looking at how their understanding of neuroscience is, and they have adopted and basically borrowed a lot of concepts from neurology and tried to implement computer science algorithms using those techniques. So if you know how neurons work, they are interconnected, right? Each neuron is connected to a bunch of other neurons. So in a very similar way, what they have done is they have started looking at individual features, individual functions within an artificial intelligence program, broken down into multiple steps, and started connecting the outputs of one to the other. And that's how they've built deeper and larger programs. And that's how the word neural networks came in. Obviously, from the first version to the second version, it took quite some time, but they have started reducing the errors. They started reducing the, it's called a gradient amplification problem. When there is a small issue or a small mistake that happens in any of the neural links, it tends to get amplified when you go down into the thread of neural networks, right? Into subsequent depths of neurons. So that's become a problem, and they have tried to solve them. It's something that is still active research that is going on with it. That has become the foundation for a lot of other deep learning techniques. Forecasting is a very simple application. This is where I think the whole of AI, if there is one aspect where it is being heavily used, it is forecasting. So simple example of forecasting that you might be very well be exposed to is your Uber cab drivers, right? Uber cabs have a way in which they forecast which area has the higher demand. So in general, in Hyderabad, in the mornings, there could be a lot of demand in residential areas for cabs. So areas like Madhapur and Manikonda would see a surge, and the Uber app basically directs all the drivers to go into areas where there is higher demand. But when it is evening, it shifts completely to the areas of High Tech City, Gachibowli, and places like this, because there is a huge surge of demand there, right? So how does it do this? They look at several days and historical data points. It looks at day of week patterns. On a Sunday and a Saturday, the trend is no longer correct, right? The trend could be entirely different. People would start going. There would not be any demand in areas of residential places, as well as not so much when it comes to the areas of corporate buildings. The demand would be completely shifted to where malls and other entertainment options exist. So forecasting at day of week level, time of day level, figuring out what kind of customers are going to be approaching you, all these things are part of forecasting in Uber. And this has also been there for a really long time. Applying artificial intelligence techniques into this has started to come about very recently. Optimization is the last part. Optimization is where operations research came into picture. Every time there is a limited resource, you want to optimize. The limited resource could be money, the limited resource could be time, the limited resource could be fuel when it is an airline. anything that you want to optimize because there is a resource constraint, you would call it as an optimization problem. The standard optimization problems, I can share one from one that is from a classic textbook, is something called as a traveling salesman problem. So the traveling salesman problem is basically you need to cover a bunch of houses to sell a vacuum cleaner, and you have to do this in the shortest distance that you're covering. So this is a classic traveling salesman problem. So when you look at this entire graph and this entire network of roads, right, you have to figure out how do you go and travel through each of these roads in the shortest period of time. Another classic problem is your Google Maps. You want to go from point A to point B, and you have to figure out the shortest route to reach the destination. So it looks at things like how much traffic is there, how much distance are you going to cover, and looks at both these equations and says, okay, if I'm moving at so-and-so speed via all these various routes that are possible, what is the minimum period of time in which I can go there, and what is the best possible route to get there? So that is your optimization problem. So these are typically the terms that we come across in the industry, and you must be coming across very commonly when you are reading up about artificial intelligence. And this is the overall picture of the commonly used terms. The terms on the right side, like I said, tomorrow Prahalya will take you through each one of them when she talks about the more workings and the inner algorithms that are part of the machine learning toolkit. Any questions? Like I said, I don't want this to be a one-way thing. That's why I'm kind of taking a pause and asking you if there are any questions. So Karthik sir has asked a fantastic question about scope of AI in determining COVID-19 victims. Okay, scope of AI in determining COVID-19 victims. All right. To be honest, there has already been a lot of research in this area on how that spread happens. But I think the biggest constraint to this is how do you start off by identifying the the already sick patients. There is an information asymmetry which is driven by privacy policies, right? So when you know that there are a bunch of people who are COVID-19 positive, to track them on a continuous basis is going to be the biggest privacy violation, as we know. China has used this very effectively through their what we call as a contact tracing app. Arogya Setu is a typical example of Arogya Setu of a contact tracing app, and you know how it has worked out, right? There's been a lot of backlash from uh, a lot of groups in terms of having privacy violations. Under which terms of AI would the above come into picture? That is a pure play optimization and a forecasting problem. What you are trying to do there is you are trying to figure out how the movement of the probability of where that virus is going to jump to, and figure out how fast it is going to be moving. It can be solved as something called as a swarm optimization problem. I will type it out. It's called swarm optimization, where in swarm optimization, you cannot be looking at individual human beings by their name or by their, by their particular ID, but you look at it as a group of people, like a bee swarm that is going around, and you can see how that expands over time using a lot of probabilities and a lot of statistics around it. But essentially, it is not, you cannot drive individual probabilities to what is the assignment of COVID-19 in a particular patient, but you can draft how much is it going to spread and at what rate is it going to spread. An interesting use case, just to add to this, Bill Gates has extensively invested on preparing these algorithms with a company called, CDC was involved in it, but essentially it was a institute for communicable diseases, right? Instead of communicable diseases, basically created a algorithm. It's a simulation algorithm that they've created, where they were trying to figure out how polio can be eradicated in places like Africa. That was their biggest project, and that's why they have used it. And that is one example where they have figured out that the extent to which polio goes from one city to the other, how that communicable diseases are being spread, and how difficult it is to stop this, this diseases to completely eradicate such diseases. So their work has been extensively in polio and in malaria, both of them in Africa. When they were trying to do it, they have created a lot of research, a lot of simulations using advanced machine learning and data science modeling. So that's something that can be applied to COVID as well, but it is not something that can be looked at for individual patients to come. In what ways can we implement AI in recommend systems? This is a question from Pramod sir. What do you mean recommend systems, sir? Do you mean recommendation systems? Okay. Sorry? Okay. He means recommendation systems. Okay. So so recommendation systems, we will talk about it in the next slide, but recommendation systems, the standard recommendation systems that we would be using in our daily lives is places like Amazon, all shopping sites where it starts giving you, this is what you should be purchasing, or you might be interested in purchasing this because you bought something else. A classic example of having, if you have bought a cell phone, you would be recommended to buy a screen guard. You would be recommended to buy a phone cover, right? Or you would be recommending to buy a earphones that goes along with them. So the core of any recommendation system is something called as a knowledge graph. All right. Knowledge graph is essentially a acyclic graph. It connects every aspect of that particular domain. If you are talking about retail, it connects every aspect of retail to another, to its neighboring aspect using a relationship. So if you look at a normal graph, for example, internet, every two things are connected with the same URL, right? So you could say that Lendi college website is connected to NIRF college website, NIRF institute's website, but it doesn't show what is the relationship between NIRF and Lendi. It is just a link. It is just a one-way thing. It's just the same thing for any link between Lendi and another entity. It could be NIRF, it could be AICT, it could be NAC. All of them will have just a straight line. If there is a student publication or a faculty member who has his own website, it will still be saying the same thing. Lendi is connected to so-and-so faculty member's website with a straight line. But when it comes to knowledge graph, the link itself is defined in a unique way. You can say that NIRF, AICT, NAC, NBA are all linked to Lendi's website from a regulatory standpoint. So that link becomes a regulatory link. When it comes to a faculty member's personal webpage, it will be linked through a faculty link, right? So all faculty member links will be clubbed in one category, and it will be linked with a unique identity. So when some AI bot, right? Bot is a software program that can crawl through these things, crawl through the internet or crawl through networks. It identifies what to get from each node to the other node. So if you say, hey, let's call that bot as Lendi bot. Say we call Lendi bot and say, Lendi bot, bring up all the profiles of faculty members who have linked their website or their LinkedIn profiles to Lendi's website. Then Lendi bot will go in and it will look at only the only the faculty profiles which are connected through this relationship called faculty relationship. So it goes and pulls up all the links of faculty members who have connected to Lendi's website by this faculty link. It does not go and pull up institutes like AICT or institutes like NBA and NAC because they are in a different category. It will not go and pick up student profiles which are probably connected to Lendi's website. It is very specific in the way it goes and moves it goes and retrieves data. So in a similar way, for a recommendation engine, for a recommendation system, the core of the problem is to create this large knowledge graph which says a mobile phone is connected to a mobile screen guard, it is connected to a mobile accessory, because there is some relationship between them, as saying these both are connected. If you look at it, this is a relationship that is directional. When somebody buys a screen guard, it doesn't recommend you buy a cell phone. But if you buy a cell phone, it recommends that you buy a screen guard. So there is also a relationship and a direction to this relationship that says when you do X, then there is a probability of you doing Y via this relationship that is established in a knowledge graph. Right? Knowledge graph will be something that we will also touch upon, because that is the core of learning science in a lot of in a lot of applications. Right? Even if you look at how Facebook recommends the second post, it's a wall. You keep getting a lot of posts from different people in your network. The next post that comes up is also driven by something called as a knowledge graph. There it has relationships like who is your friend. So it can say that Yashwanth is a friend of Acharya Garu, and Acharya Garu is a friend of Anjireddy Garu. And then when it recommends saying that, hey, you know what, because you are friends with Acharya sir, it could be that Anjireddy sir is also a probable friend for you, and it throws his link on top of my web page when I look at a Facebook, when I open Facebook. That is where your recommended friends portion comes in. So typically all recommendation systems, the core aspect when it comes to learning, when it comes to recommendation engines, it becomes a knowledge graph. So in this previous slide, you see this knowledge bases. So the example, this is more of a foundational thing. Knowledge base or knowledge graph is basically the foundation that is required to do an example system like a recommendation system. I hope I have answered your question. This was a question by Pramod sir. So the next question is from Bhaskaran sir. Is Gmail AI personalized for each and every person, or is it generic? Fantastic question. Okay, so this is where hierarchical personalization comes into picture. So the way it works, I'll explain it to you in a very brief way. This is something that Gmail took a lot of time to figure out because of privacy issues. What it does is there is a hierarchical personalization, by which what I mean is there is something which is extremely generic, where your parameters are across all the population of Gmail users. So there are trends that are true for every Gmail user across the country. The example that I said, where I say hi and then it gives it gives an auto recommendation of the person whose name is in my to box, is an example of a trend that is across everybody. That is the first layer. The second layer is something which is specific to that region or that language. For India, it could be namaste, could be a word that is part of the vocabulary within an email. Right? How does it know that? Because it has ran through and it has processed the entire country's Gmail accounts, and it has figured out that namaste in English, NAMASTE or THE, or in various formats of the word, is something that is very often used as a salutation within an Indian email on Gmail. Right? So this is where your hierarchy number 2 comes into picture, where it is looking specifically at a country level or a geography level. The third level could be very specific to how you as a person are writing email. And in between, there could be 4 or 5 layers. But essentially, at the bottommost layer, if you have enough amount of history of Gmails that you have written for that particular account, it will scan through it and it will have it as the highest layer of personalization, where you could be typically using a word like always be using something like regards, and then you sign off saying regards Yashwanth. I use it as I might be using something like regards Yashwanth. It will constantly keep recommending the same closure on my email because it has seen that historically I've been using the same thing. For Bhaskaran sir, it could be thanks. He could be just signing off saying thanks Bhaskaran. So then it turns out to be a different case for the example of Bhaskaran sir. So it depends on on multiple layers, and this is a classic example of hierarchical clustering. In hierarchical clustering, you do aggregation at multiple layers, and then you recommend something depending on which of these hierarchies have the highest weight. So depending on uh, how how strong in terms of probability you are when you're recommending something, it takes the precedence and says that, okay, I know for a surety with 95% sure that at this point in time, Yashwanth typically says thanks or regards and then signs off, right? So that's when it generally drops off and says, okay, regards is the highest recommended thing. If it was somebody else, it would pick up something else and says, I'm not confident because he keeps changing between regards, thanks, and namaste and several things. So I will not recommend something. I will fall back on the global common thing, which could be just saying thanks, and it recommends that as the default option. So it depends. It basically depends on multiple layers. It is a hierarchical clustering for which it uses when it comes to personalization. Thank you, sir. Thank you, Bhaskaran, sir. The next question is from Meher Shilpa. Madam, I think, how important AI in robotics? Can you please suggest any research in this field? Sure. Okay. So AI in robotics, I think we will cover that in the next slide. We have this coming up. So I will touch upon one example in each of these industries. There are about 12 sections that I've written. I'll pick up one example in each one and talk. Maybe I will cover robotics. Robotics is right here. So I will cover that aspect also when I'm talking about robotics. Otherwise, you can ask me again about the research fields. I'll definitely get back to it. Role of AI in the field of electrical engineering. This is Prasanna Kumar sir who has asked this question. Is electrical engineering part of this? Okay, so electrical engineering, again, there are a bunch of use cases that I can think of, but if you let me, I will complete the overview of application slide and I will come back and I'll probably touch upon that. Okay, let me do this. In this slide of the 12 items, let me start by talking about self-driving cars, which is today's prime example. I mean, everybody is talking about self-driving cars, right? And then we will touch upon robotics, and then we will go to the rest of them. So there are 12 use cases. We can, if anybody else has any more questions, we will talk about all of them and then take some more questions. So I will jump into the example of self-driving cars and how self-driving cars use a lot of AI in them. So can you imagine the amount of information that a self-driving car takes into account on a second-to-second basis to make decisions? Some of you take a guess. I'm not expecting you to know the answer, but if you can give it a shot, is it, say, 100 MB per second that a self-driving car consumes, or is it 1 GB, or is it more than that? How much information do you think is a self-driving car consuming? That's the question for you. Anyone wants to take a hit first? Okay, 1 MB. Karthik sir says 1 MB. Bhaskaran sir says it's in GBs. What is Industry 4.0? I will touch upon Industry 4.2, Kalyan sir. Just give me 1 minute. But I want some more responses to that question. How much data do you think a self-driving car consumes or takes into account when it is making a decision? Just think of how many things that a human driver takes into account when he's driving. Then you will probably get an easy answer. Tera and terabytes of data. Bhumik has said that it's about KB. All right. So the answer on a per second basis, it's about 100 GB. It goes into terabytes it depends on the kind of the kind of optimization that goes into the car. But Tesla cars, when you look at it, they take about 150 GB of data every second. So this data comes from every aspect of the car, and significantly there are three kinds of data that it consumes. One is from what we call as the lidar, which is something, it's more like the um, acoustic recognition system of what is there around the car. It takes care of the geospatial entities, where other cars are present, where other objects are present. That is for the external visual things, which is the primary thing when you are thinking about driving a car, right? You need to see what is around you. So that is the predominant amount of data. At every second basis, at a second to second basis, it is consuming a lot of information. Second is, it is surprising, you might be surprising that there is a lot of video that happens within the car. It keeps looking at what is happening within the car. It looks at whether there is a driver in the seat or not, whether the driver is holding the steering wheel or not, how many people are there inside the car, all kinds of attributes within the car, even to an extent of whether there are kids in the car and whatnot. All kinds of information is collected from inside the car. So this is a very common mistake that a lot of people think that when you talk about a self-driving car, all the cameras are outward looking. No, they are not always outward looking. There are a bunch of cameras that are looking at who's actually inside the car and who's actually driving the car. The third aspect, which is another surprising thing, is the audio of the car, right? What kind of audio is being generated around the car? You think of it as a car going on a wet road versus a dry road. There is a different kind of feedback that the system gets when it is going on a wet road versus going on a dry road. And that's an important component in understanding the speed, in trying to understand how much of brake application can happen, and in all kinds of things when it comes to self-driving cars. The point of data, right? How is all this data going to be? Where is this all going to be? There are obviously two computers in self-driving cars. One is the onboard computer, where all the processing happens within this computer, which stores about 24 hours of data. The rest of the data, as and when it keeps getting new data, it's being sent or transported back to the servers, back to the cloud. And cloud backs up all this data for future software updates, future engaging in more R&D to make the self-driving system more safe and things like that. The cost of storage is extremely low, and that was one of the key drivers of making artificial intelligence applications in real-time systems. Self-driving car is a classic real-time example, right? The real-time system, right? So if you look at how probably an image recognition happens, there are image recognition that happens over a video, where in live you need to tell, okay, here is Yashwanth in this video. And there are other things where you have post processing, where you have all the video already recorded, or you have a bunch of images already present, and then you are trying to tell what kind of, whether there is somebody in that video or not. So real-time systems are much more optimized. They have to be driven in microsecond rates. They have to be processed at such a large level. And self-driving cars, when it comes down to so much information that is flowing in, the algorithms have to be really, really optimized, and that's where a lot of AI comes into picture. A traditional rule engine will not work when it comes to complex systems like self-driving cars. Not just self-driving cars, a lot of nuclear related projects, autopilot in an aircraft, for example, right? They are driven by large systems and large computational capacities that are on board to ensure that all the avionics, the kind of differences in weather, wind speeds, temperature of the engines, all these are taken in as a constant input, and you're trying to figure out what should be the next move. So that's where self-driving cars come into picture. So AI in self-driving cars get used. Logistics is I'm going in the reverse order. I'm hoping that you are all following. Okay, so here is a question on how much relevance that RTOS, real-time operating system, has in AI world, right? So this is an example, a classic example of where real-time OS is being used in a AI world. I am not 100% sure on how you would classify an operating system as real-time. I have not come across that terminology, but I think I'm guessing this is what you're referring to, where you have systems where a lot of real-time decisions are being made, and your processor and the kernel needs to be engaged in such a way that these things are being operated at that level. So if so yeah, so that is with the aspect of self-driving cars. The second thing is logistics. Logistics is again a lot of optimization that happens. How do you come up with routes, especially for large sea link and large naval naval movements that happens, logistics space, supply chain management, and several areas where you are optimizing resources and trying to reach the destination in the shortest possible time. Uh, a classic example here is, again, the logistics is closely related to the airline space that I come from. Typically, if you imagine the period of time before which the planning is done, it is done 12 months in advance. So if you are looking at how to deploy aircrafts to move systems, to move freight across continents, they are deployed 12 months in advance as to what each route has to take, what kind of carrier each route has to have, where should you put Boeing 747, where should you be putting A350s and things like that. So this is another complex optimization problem, because you have to forecast what is the demand going to be, and then deploy the enough capacity in those areas to ensure that you get maximum money and you're moving resources at the right pace. A standard problem that happens is when things like COVID happens, when you are actually putting down 50 aircrafts to fly between Europe and US, you end up with demand which is less than 5, and you have to quickly relook at how you have to repurpose the rest of the aircrafts. And if you're shutting down some aircrafts, what is the best aircrafts to be shut down? So this becomes a large complex problem to be solved in a very, very short amount of time, and those are the places where you have these operation research algorithms that come into place, right? This is where your systems like, how has it happened in the last 10 years when there was a disruption that happened? This is called disruption handling. How a disruption has caused the systems to move within the constraints of an airline, and how do you minimize the impact on your revenue, impact on the cost structure of the company, to have the least loss at the end of the day. So that's where logistics it's used. Fraud and risk detection is an area where HSBC has been doing a lot of stellar work. When you swipe a credit card, right, if you are a Visa card, then it goes through the Visa platform, it goes through the bank systems, it goes through the payment processing, it goes through your accounts and says whether you have enough balance or not, are you within the limit or not. And there is one element which is called as the fraud detection system. In your fraud detection system, it looks at how you have been doing transactions in the last several years, and whether the new transaction is falling within within those constructs. For example, if you are a person who is doing a transaction in Hyderabad today, and tomorrow there is a transaction that happens in Singapore, it will say that probably it is you who have done the transaction, because there was a 24-hour window between your transaction in Hyderabad and your transaction in Singapore. But if you do a transaction in Hyderabad and within 45 minutes there is a transaction in Singapore, it flags it off as a high risk transaction, and it will actually stop the transaction from going through, because the system is smart enough to say within 45 minutes there is no chance that you will be going from Hyderabad to Singapore. This is a very, very simple and a standard example that all fraud detection companies, all banks basically use. Huge scope of work that is going on, primarily driven by machine learning algorithms. One interesting area when it comes to risk detection, risk and fraud are different. When it comes to risk detection, it is things like, have you had insider information in making a transaction? Say, suppose you have within say a bank like Goldman Sachs, they are part of several transactions that are happening within the market. So they have systems where it scans through all the emails of their employees, and if somebody as an individual, as an employee, does a transaction in which he's involved, right, for his own personal gain, it immediately flags it and says, hey, you know what, you are doing a illicit transaction, this is not supposed to be done, and it flags off, and that might lead him for an immediate termination. So those kind of systems, they constantly keep running through all your emails, all the transactions that you're doing on your demat account, and it says that, hey, you know what, this is not happening. Robots is an area where it excites everybody, right? Right from amazing movies that came out to science fiction, robots having knowledge and being able to interact with human beings is a huge subject of research. The most advanced robotic institute as of today is the Boston Dynamics, a company that Google bought, almost 10 years back, and they are doing some significant research. But more beyond Boston Dynamics, the country that is doing advanced research is Japan. Japan almost came to an extent where they are able to create a robot called as Erika, which is going to be a newsreader. It's going to, the reason why they have done it is because human newsreaders tend to be biased. They have an affiliation to a particular political party, or an affiliation to a specific individual human being. So they tend to take sides when they're speaking about a news article, but the objective is for having a newsreader who is completely unbiased. And that's where their research, and that's where their progress has been going in the last few years. Another aspect of robots is robots can technically do a lot of repetitive work, right? So their human barrier, or human limits to lifting weights is limited. Probably a human being cannot lift, more than 250 kilos of weight. Even a superhuman probably does up to 250 kilos. But if you have a robot, the amount of weight that it can lift is technically very large. You could keep going and going. It could be 5 quintals, 500 kilos could be easy for a small robot. So making robots do things, we have already done that, but having a human like robot is the biggest challenge for the industry right now. How do you make a multi-purpose robot? A multifunctional multi-purpose robot is the next biggest area where research is happening. So I think there was a question from on what is the where are the areas of research when it comes to robotics. Well, one of the most important research topic that is happening right now is around the area of social robots. How do you create robots that are indistinguishable from human beings, right? That is a huge area, be it from a computer vision perspective, natural language processing perspective. How do you create a sense to the interacting human being that they're actually talking to another human being and not a machine? So this is within this, there are a lot of sub research topics, starting from mobility in a social way, understanding jokes, having a context of talking to a robot, the robot understanding what you're actually talking about without giving explicit information to it. Alexa and Siri are actually in a very nascent stage of understanding what humans say, right? How many of you have had a great experience talking to Siri about an open conversation? Not many. It is still way years and years away from replacing a friend, right? It is still executing very, very simple simple statements like how a child would implement. It doesn't have the intelligence to hold on a conversation for, say, more than 5 minutes. Humans would get bored of it, right? So robotics is obviously a very large area. We will try to cover few aspects of how robotics works within our case studies. Gaming is another area where AI is being used. I don't know. I think very few of, I don't know how many of you actually play a lot of computer games, but gaming is an area where, when you are traveling through the experience of a game, there are elements within the game that are changing based on your behavior. So there are the entire layout of the game would keep evolving as you keep going through the journey of gaming, because the system also keeps getting better and better, right? So computer games, the application of AI in terms of making it more visual, more engaging, is humongous. Augmented and virtual reality with AI, right? That's, I think Karthik sir has just mentioned that. That's another huge area where augmented and virtual reality is primarily machine learning. It is driven by figuring out how do you make this actually possible with limited amount of computing power and memory power. It is not a problem in terms of the algorithms per se, but it is mostly to do how do you make augmented and virtual reality possible from your cell phone, from the processor that is there in your cell phone. Because today's AR and VR media devices or media is requiring huge amounts of computing power. Typically they are connected to the servers, and typically you need a huge network bandwidth to make these things happen. But if you have the right kind of AI and ML algorithms running on your machine, it is possible that you reduce the computational requirements of that, of running an AR VR media component. So that's where AI is applied in gaming. Airline route planning, like I said, logistics and airline route planning, huge amount of machine learning that is used there. It looks at all the several combinations that a human being can travel within a particular airline network, looks at all possible combinations and tries to optimize it for maximized revenue. So this was one of my areas of work when I was working with Etihad and Sabre. We used to look at close to 240 thousand combinations of a person going from point A to anywhere in the world, and we used to figure out how many such people exist, and based on that demand of people we used to optimize the entire network. And there are multiple cool things that you get to do when you're looking at airline route planning. Now I'm going to the top layer, and in the top section we have speech recognition, image recognition. Speech recognition and image recognition both are, I would say, the building blocks for you to build robots, for you to build self-driving cars, for you to do healthcare, for a bunch of other aspects, other technologies and other innovations. You need fundamentals of speech recognition and image recognition. Image recognition also don't limit it to just photographs. Image recognition can go anywhere from your script where you are writing things and it has to figure out what you have written, to all the way to figuring out in a real-time video what is going to happen, what is your next move going to be. So there are systems that can see all these prototypes, right? Prototypes have infinite resources. You could use a huge computer and a huge server to run an image recognition software in real time for close to 10 minutes. That is not a real usage of it. When you have it in production, you would be running the tool for close to 24 hours. It would be run 24 hours on a daily basis. It's a 24/7 operation, and there are a lot of engineering problems that get along with it, other than just the scientific, that one small research piece where you're saying that I'm able to do image recognition in microsecond efficiency, or I'm able to predict what the next move of a person in a video is going to be. So while there are prototypes for all these things, image recognition is still not so commonplace. Within image recognition, there are aspects which are basic comparisons, and there are methods in which your laptop's facial recognition system works. Right, you don't have to enter a password; it directly looks at your face and says, "Hey, welcome," and it signs you in. So from there to bank transactions that happen based on facial features, there are a bunch of things that is happening in image recognition. Because once you solve the image recognition problem in the best possible way with the highest level of accuracy, you technically don't need credit cards, you don't need debit cards. You don't need any kind of ID cards when you're entering your office room or you're entering your college. Everything is done because there's a security camera that keeps looking at you, and it says that, all right, hey, you have come in, I'm marking your attendance, done. You go in and you can access whichever place you want. If you don't have authorization to get into a certain perimeter within a research facility, it says you are not authorized just by looking at your face. It's not going to it's not going to need any other kind of permissions. And the best part is it's contactless. Image recognition, you don't have to touch anything for your biometrics. You don't have to put in your fingerprints or give your iris check, nothing. You just walk through it. And just like how a human security guard would see and say, I know this person, he's part of the, he's cleared the security check. The same way a computer or a camera could do that for you. Just imagine the kind of freedom that it will give you, right? So image recognition, and the same way with speech recognition, these two are considered to be the last barriers that are stopping humans and machines to communicate freely, where you can also talk to the machine and it talks to you back and it understands you 100% the way you intend it to understand. And this interaction can take the human race to the next level. So that's with image recognition and speech recognition. So essentially they are the founding blocks of lot of other innovations, that lot of other technologies that we talk about. Recommender systems is what I was just talking about. So once you have a knowledge base, once you have a knowledge graph, it is very straightforward for a bot to traverse through it, and then it starts giving you the right kind of feedback and right kind of recommendations as you go along. Targeted advertising, right? This is also very much, if you look at it, it's the flip side of a recommendation system. Instead of it looking at what you are going to purchase, it is going to look at what you are going to click on a screen, or on a laptop screen, or on a mobile screen, and it is going to be a much wider set depending on how you have interacted with another website, or how you are been behaving for the last few days on a particular topic, your interest levels in certain topic. It starts popping up the right kind of things. Now targeted advertising has gone to the next level. Google has integrated their Google Assistant's inputs into targeted advertising, through which if you even talk casually to your friend about say going on a trip to Kashmir, it starts popping up tours and packages to Kashmir, or things that are happening in Kashmir, or flights that are cheap when you want to go to Kashmir. It is becoming such an intrusive thing. There is a huge ethical side also of it. Is it okay to hear what people are talking when they don't intend you to be a listener? Because the Google Assistant is always on, right? It keeps looking for that keyword of okay Google before it jumps into life. So it absorbs all this information, processes it, and when you open up a next website or a web link, it starts showing you recommendations saying, hey, this is something you would be interested in. And it gets really eerie when you keep seeing it, all these things that are coming up even without you searching for it. The next thing is internet search. I think from Google, when it started in 1999, from a simple page ranking algorithm, the way it has come till now is amazing. I am sure most of you have observed that knowledge box that is very popular in Google right now. So when you Google for something, there is a box that appears on the right side that shows, a small link from Wikipedia, and it answers your question. That's also because they have processed so much of search queries over the last 20 years. They've been able to come up with a system where you don't have to click another link to find an answer to your question. So that whole process of going and clicking on a particular link after you have Googled for something, they want to eliminate that step. Whatever you need and whatever is the answer that you want, you will be satisfied with. They have started popping up onto the main page itself, on the search page itself. This has been a project for about 5 years at Google, and I think in 2016 they have launched it, and it's become a huge hit. As I think you must have also already taken advantage of that. You don't have to click too many times. Healthcare is where I think it's the most promising field. Right from the most important thing is radiology. Obviously, this is where extensive application of AI is happening. Pre-checks, pre-clinical trials, pre-diagnosis, All these things are happening at healthcare, where somebody gets scanned for a cancer. Even before the radiologist gives his prediction, the system itself scans through the entire reports, builds up an methodology, and says this is the percentage, this is the probability of that person having a tumor in this area. So it marks out where there's a probability of tumor, and that's where the doctor can focus and make a decision. So it's healthcare and AI are called are always stated together in terms of changing the complete human existence in itself. The amount of things that are possible with artificial intelligence in healthcare is huge. So there's a lot of interest that got generated in this sector. Any questions on this overview? Hello? Dr. Bindu has said that it is not audible. Am I audible to anyone else, or is it a problem with everyone? Anji sir, can you hear me?
Yes, yes, sir.
Okay, I guess it is a problem. So I think it's a network issue. So we are already at 5 o'clock. So I will, this is what I had as my last slide for the evening. We are, I think, pretty much there. So this is the foundation and history that I wanted to quickly run through. So the bunch of things here. So I will go to the most important part, which is the 1950 Alan Turing's Turing test. So in a very short way, if I have to define what a Turing test is, it's the most comprehensive test when it comes to artificial intelligence and where we stand when we talk about artificial intelligence. So what it says is, a true artificial intelligence system, if it exists, then a human being cannot separate that system versus a human being in itself. So the test has been spoken about in this case. There is a human in one room, and there is a machine or a computer in the other room. There is a an interviewer who comes and sits in front of each of these rooms and starts talking to the person in the other room. So there is just a curtain, and you can't see what is inside. You keep talking to that person over conversation, and if you cannot differentiate who is the human and who is the computer, then that computer has won in the artificial intelligence test. That is what Alan Turing has said. You might, I mean, all of you might have known or heard this name, Alan Turing, before. He's the father of artificial intelligence, as they call it. His Turing test, his contribution to computer science and to biology, to cryptography, to a lot of areas of research is just insane. There has been he's so famous in computer science that the highest laurel that a computer scientist can get is the Turing Award. It is equivalent to a Nobel Prize in in the world. So Turing's award is the equivalent of Nobel Prize when it comes to computer science, and it is for his contributions that he has made, the founding definitions of languages, machines, and computations. All these things, Turing's name keeps resoundingly coming. His contribution to cryptography as a huge field in itself has been immense. So he has defined this Turing test, which separates human intelligence versus artificial intelligence, and how they can be called as a perfect AI system. And over time, 50s and 60s, it has evolved. The term AI got coined. There were movies, and so the pop culture started to come up, and people started talking about AI. But I think a lot of work later, the second biggest milestone happened in 1997. So if you can see 1997, that's where IBM's Deep Blue computer that beat Gary Kasparov. I'm sure most of us remember those newspaper articles and people talking about how a machine has actually beat a human being at chess, and not just any human being, but the champion of chess back in the day, Gary Kasparov. So that has been a seminal moment, kind of a changing moment in the history of artificial intelligence. And then 2000 to 2010, there's been one huge explosion of internet. A lot of data started getting generated in 2010. In fact, because of super fast trading and several new AI driven initiatives in Wall Street, it is said to have crashed the Dow Jones average, which is their index, and it actually crashed by close to 1,000 points. So the influence of AI on real world and the scare actually began with 2010, when they saw that there are real challenges that can happen when if artificial intelligence is not dealt carefully. And then 2011, Siri came in, Amazon Echo came in, AI partnership started, and direct your attention to 2016. 2016 is when Microsoft released a Twitter channel, a Twitter individual called as Tay, Tay. Tay is a AI-based channel. It is supposed to be mimicking a 19-year-old American girl, and it was brought down in less than 16 hours. Just imagine that. In 16 hours, they launched it and they had to shut down because it evolved so quickly and started making a lot of defamatory comments with the rest of the users. So within a very short period of time, within 16 hours, it had close to 3 million conversations with other users of Twitter. And they had to quickly get it down because they understood that it is going to be uncontrollable. And in words of Satya Nadella, that particular incident has changed the entire way Microsoft looks at artificial intelligence and its implementation. So they have actually brought back a lot of products, looked at very controlled way how it is growing, and then started to release them in parts. So that's become another seminal movement. And then from 2017, the last line is basically something that you must have been reading in the news: the Cambridge Analytica and how Facebook data has got manipulated during the last elections in the US. Erika, the robot that I was talking about, which is a news anchor in Japan, and most recently a genderless voice for the first time. It's called Q. They have created that, and a lot of other research that is happening on deep fakes and how fake news is something that is happening popularly. All these are happening and they are being seen as the negative sides of AI, but a lot of promise lies in the positive side. These are the things that will draw onto the ethical, the separator, saying that whether we can go full-fledged with artificial intelligence, what are the limitations of that, where can we implement it, and how we have to be careful in terms of implementing. This is more from a extension of what we already have, kind of a landscape. So this is what I had planned for today. I think we are a little over, it's 5:05, so we are 5 minutes off our track. But if you have any questions, if there is somebody who wants to talk about anything else, or you want me to repeat myself anywhere, I would be more than happy to talk. I think here comes the feedback form. Oh, we have about 63 participants, not bad.
Good season, sir. So I request participants, if anyone wants to ask the questions, you can ask. Please raise your hand so that I will unmute yours.
Thank you, Bhaskaran sir. I thank you for the excellent participation that many of you have shown. I know it's 3 o'clock and post lunch it might be a little sleepy, but yeah, it was very exciting from my side. There were a lot of interesting questions. We will deal with them tomorrow and day after tomorrow as well.
Yes, sir. Questions, anyone? Okay.
And all the questions have been covered at your session itself, sir.
Oh, thank you very much.
It's a real. This is Varma, another TNP coordinator. Thank you for your beautiful session, sir. Really, it is very informative. Your explanation was really very good. You came from the scratch. You explained in detail about each and everything. It's very wonderful to listen to you, sir.
Thank you.
Thank you very much,
sir. One more thing.
Yes, sir.
Around 18 states, from 18 states, the participant has been registered for this.
Oh, wow.
Across India.
Awesome.
If I am not wrong,
from Jammu Kashmir to Kanyakumari.
Wow, wow.
Fortunately, I have seen many participants.
Anjireddy Garu, if I am not wrong, there might be one international participant.
Yes, from France also. One of my alumni student.
Brilliant.
Registered from the France. Right now, he's working in France.
Okay.
So, yeah.
I think it's a
good thing,
great.
sir.
Yeah, I felt really happy talking to all of you. I'm really surprised and excited to see that participation has come from all around the country and not just within the country, but all the way from France. It's beautiful. Thank you, Varma sir, for all those kind words. I'm very glad that I could make some sense to all of you. In the feedback, whatever you have received, if you can share it with me, in our next 2 days, I'll be taking half the sessions, and Prahalya ma'am and Vayasrao sir will take the other half. So we can factor in those conversations and that feedback and make the next 2 days more exciting. And I'm always up for a lot of questions and a lot of participation. So we will definitely do it. There's a Vamsi Krishna sir has said that you should take a data set and show something good. We will try to do that on the last day. We have a couple of examples that we wanted to show you in terms of industry use cases. We will not be able to do the full Python programming and implementation standpoint, but we will just show you how we started from the data and we went along, various steps of cleaning and how we processed it and what kind of tools that we have used in getting where we want to go. We will take something which is a little exciting for everybody, something in image recognition, and try to break it down and get everybody to get a sense of what happens in a real AI project.
Thank you very much, sir. Definitely, Anji will share you the feedback responses also.
Sure. Awesome. All right.
Okay, sir.
Okay, sir. Thank you very much.
Sir, I would like to thank for your valuable knowledge sharing with us. Again, I would like to thank you, sir, for wonderful opportunity to listen your knowledge.
Thank you very much, sir. Thank you for inviting me and the Edwisely team. We will, we will again meet tomorrow at same time,
Yes.
3 o'clock.
Yes, exactly.
And we'll take it forward. All right.
Okay, sir.
All right. If you have any questions beyond that, you can put it in the feedback form probably. And once Anji sir shares it with me, I will also run through it. If there is anything, we'll start tomorrow's session with some, some of these questions, answering some of these questions, and get into the main topic. Okay.
Yes, sir. Okay.
Okay.
All right. Thank you very much, sir. Have a great evening, everyone. Thank you very much. Bye.
Bye, sir.
Request all the participants to fill the feedback form.
Okay, sir. Definitely, sir. Sir, can we leave, sir?
Yes, sir. Yes.
Yeah.